So I want to go through some more examples of factoring. So I thought we'd take some time and work through several. Remember that the one thing you want to do when you are solving by factoring is to make sure that your equation is equal to 0. So we have an equation here. We're checking that it's equal to 0. It is, so we are ready to start factoring. So remember, you're going to break this apart into two sets of parentheses, and we're going to put a D in the front of each one. Now notice we're using all kinds of different letters here. It doesn't matter. They're all the same thing as X. You use them the same way. Um, and now we're looking at the 25, and we want to know what multiplies to make 25 and also adds to be negative 10. So as I think through the factors of 25, my choices are 1 and 25 or 5 and 5. Well, I know that 5 plus 5 makes 10. The problem is I need a negative 10. So how do I add them to make a negative 10? Well, to go back to 25, remember that negative 5 times negative 5 also makes a positive 25. So we could have, instead of both of these signs being positive, we could have them both be negative and still get a positive 25 when we multiply them together. So in fact, our equation is now d minus 5 times d minus 5. That we can solve, and we find that d equals 5 twice. We have two answers that are the same. D equals 5 for this equation. Looking at the next one, here we've got x squared minus 5x equals 0. We're missing that constant term. So let's think about what that means in the function. Technically, what that means is that we have x squared minus 5x plus 0 equals 0. When you think about the factors of 0 that add up to be 5, it gets a little interesting. So what I want you to do is I want you to think back to factoring. I'm going to cross this out. Think back to factoring and other tools that we have for factoring. We can also factor out something that they have in common. In this case, I noticed that both terms have an x, so I'm actually just going to factor an x out of both of them, which leaves me with x on the outside and then x minus 5 on the inside of the parentheses. I'm still multiplying, so the zero product property still applies, which means that I can take each of these and set them equal to 0. So x equals 0 and x minus 5 equals 0. Well, that x equals 0 is already solved, and I know that the other one is going to be x equals 5. So my two solutions here are 0 and 5. Looking at this next one, we've got b squared minus 7b, and I am going to right away subtract that 18 to get it to the other side so that my equation is now equal to 0. This might be a good time to pause the video and see what you can come up with as factors of 18 that subtract to make negative 7. Hopefully you came up with 9 and 2 for that, because 9 times 2 is 18, and 9 minus 2, of course, is 7. But the question becomes, how do we get the signs to work to make negative 7? So we know we're subtracting, so either it's going to be positive 2 minus 9, or it's going to be positive 9 minus 2. Well, to get a negative 7, I need to take a positive 2 minus 9. And then, of course, to get my answers, I'm going to take the opposite of the parentheses, which gives me b equals negative 2 and b equals 9. Both of those are my solutions. All right, here we've got one that's a little interesting. It would be pretty easy to move that d squared over to the other side. However, remember what I said about you want to keep your squared term positive. So what I'm going to do is I'm actually going to subtract 12d and add 36 to the left side. That way my d squared term stays positive, which makes it much, much easier to factor. When that d squared term or x squared term or whatever becomes negative, you have to factor in a negative sign and it gets kind of ugly. So if you can keep it positive, do so, okay? So now I want to come up with factors of 36 that will add to be negative 12. Well, 6 times 6 makes 36, and I know that those add to make 12, but how do I get it to be negative? With a negative 6 and a negative 6, which means that I only have one solution. It's the same for both of them, and that is d equals 6. Hopefully this has been pretty easy for you, some extra practice in factoring, and you're feeling a little more confident about factoring trinomials.